Hey, so it was requested that I make a video of the review, so I have a very limited window right now, so I'm just going to get a couple of problems out of the way. So our review starts right here with a little bit of vocabulary, and a blanks of a circle is a line that lies in the same plane and intersects a circle in exactly one point. Well, that's a tangent. Anything that a line that intersects a circle in exactly one point is known as a tangent. Okay, number two, the set of points in a plane that are a fixed distance from a given point is actually the equation of a circle. Number three, an angle whose vertex is the center of the circle and whose sides contain chords of a circle is a central angle. Now, that's a lot of words, but they're saying if we go like this, these are both going to be not chords. Those are, sorry, radii. That's going to be a central angle. And then the last one, an angle whose vertex is on the circle, like this, is an inscribed angle. And this is the one that I wanted to say chords, because both of these things are chords. Okay, like I said, I have very limited time, so I'm just going to go ahead and move on a little bit further. But in this problem, you have to really watch. And one of the reasons we like to go ahead and print these worksheets out instead of just assigning them out of the textbook is it really helps to write things. And this says angle ABC is 38 degrees. That's up here. Now, keep in mind, this is a central angle, and that's kind of important. Because if it's a central angle, then AB and BC are both radii, and so they're the same. And so I know that if this is an isosceles triangle, as soon as that base angle is 38, then so is that. So together we have 76 degrees between the two of them, which means this angle right here for A has to complete the 180 degrees to make that triangle. And that means that this angle A right here has to be 104 degrees. Again, I just took 180 and I took off the 38 twice, right? I'm going to take off that 180 and take off both of those 38s for those two, and I'm at 104 for my central angle. So the measure of angle ACB is 38 degrees. Measure of angle CAB is 104 degrees, and CDB way out here. Now that's a tricky question because if this is a central angle, that means this arc right here is the same in 104. But try not to go too fast here. That means that the angle down here should be 1/2 because an inscribed angle is half of the arc. So if this is 104, that means the inscribed angle is half of 104, which is 52 degrees. Now, just trying to finish this up as much as I can. I'm going to see if I can get through these last couple. Now, as it turns out in this problem, these are both tangents to the circle, and there's a couple of things to note. One is that the tangents are the same as each other. So I know that 21x minus 5 is the same as 17x plus 3. So if I subtract 17x's, and I add 5 to both sides, I got that x is 2. And that's great, but that's not quite what I need. I need a little bit more of that. And if x is 2, I get 17 times 2 is 34, and 34 plus 3 is 37. And up here, it tells me that my radius is 5. So as we go through there, we've got a few of the things at play. Like, for example, I know that FG is 37. EG, on the other hand, is kind of important. And I'm skipping around a little bit, but I'm going to get there. I know that I could do A squared plus B squared equals C squared to find the length of that hypotenuse. So let's see what happens. If I were to take 5 squared plus 37 squared and square root that, I would find out that C is the square root of 1394, which is 37.3. So that actually kind of surprises people that it's relatively close in size to this side that is 37. Now, the other thing else, I said EFG, which is up here. I guess I already knew that was 90 degrees. I used that. And here's where it gets a little bit harder. The angle FEG is this angle right here. And it turns out, since we have a right triangle, I can use a little bit of trigonometry. And I know that the tangent of the angle is the side across from it divided by the adjacent side. So if I ask my calculator to take the inverse tangent, that goes backwards and goes to find that angle, the inverse tangent of 37/5, I would find out that that angle is, hard to see on there, but that's 82.3 degrees. So I use the inverse tangent. So HEF, well, if this is 82, then this one would also be 82. So I just need to double that angle and I'd get 164.6. And absolutely last, I wanted to find FGH. FGH. Well, again, because I know this angle is 164, and this is a 90, and this is a 90, this whole thing, 1, 2, 3, 4, is a big quadrilateral. So I'm going to add the 180 I have right here, and I'm going to take that away from 360, and I got 15.4 degrees. Now, that's about as fast as I can go because I've got a meeting starting in literally 1 minute. So I'll have to finish this later. I'll see you back in class. Bye-bye.